Hey, good morning. So our lesson is about horizontal distribution of shear. In this problem, a single story, you have to take note of the problem, okay? So because I'm not going to write it. A single story building has a rigid roof diaphragm. Shear walls resist lateral forces in both directions. So as shown in the figure, all directions merong shear wall, diba? All sides of the building. The mass of the roof can be considered to be uniformly distributed. And in this example, the weight of the wall is neglected. In actual practice, however, particularly with concrete shear walls, the weight of the wall should be included in the determination of the center of mass. Pero dito, ine-neglect natin yung, for the purpose of easier computation. Okay? For us to inassign kasi natin that the center of mass is the center of the area. That's why nineglect natin yung weight of the shear wall and the weight of the roof is uniformly distributed. That's why the center of the mass here is on the center of this area. So, but in reality, class, you have to include the weight of the walls, particularly in concrete shear walls. So, the following information is given. Okay, I'm going to write the information. You have to write it also. V is equal to 450 kilonewton. RA, yung rigidity nito, RA is 54 kilonewton per millimeter. And RB is equal to kilonewton yan. 18 kilonewton per millimeter, and RC equals RD is to 36 kilonewton per millimeter. And the location of the center of the mass, location niya, XM is 24 meters and YM mali. Location niya ay X is 12 meters and YM is 6 meters. Kasi andito, ito yung center of our mass. Itong ganyan na to. Here. This one. That is the center of our mass. Kaya andyan yan kasi inassume natin na the roof is uniformly distributed and the wall does not contain, and neglect natin yung weight of the wall, but in reality we should not neglect that one. So determine, so para saan to? So our lesson is about horizontal distribution of shear. So the first thing that we're going to determine is the eccentricity and rigidity properties of each wall. So required, dito ka na ilalagay. So eccentricity and rigidity properties, direct shear walls, direct shear walls of A and B, and ito kasi yung yung direction kasi ng shear natin ay pa ganito. If you can see, ito siya. That is the direction of our shear. Kaya ang affected dyan ay shear wall A and B. And the 3, plan irregularity requirements. I-check natin. Especially in torsional irregularity. Torsional shear. So, maliban sa direct shear, meron tayong torsional shear in walls. In walls A and B. Bakit A and B yung affected na wall? Kasi ito yung direction. This is the direction of our shear. So, ang affected ay ito at saka ito. So, itong C and D, we can neglect that because ito lang naman yung thickness na ire-resist niya. Okay? And 5, the total shear. Total shear means i-add natin yung direct shear and the torsional shear in walls A and B. So, in walls A and B. So this is horizontal distribution of shear in shear walls. So I'm going to repeat the problem. A single-story building has a rigid roof diaphragm. Shear walls resist lateral force in both directions. The mass of the roof can be considered to be uniformly distributed, and in this example, the weight of the wall is neglected. In actual practice, particularly with concrete shear walls, the weight of the wall should be included in the determination of the center of mass. The following information is given. The design base shear is 450 kN. The rigidity of the walls are given. For wall A, it is 54 kN per millimeter. For wall B, it is 18 kN per millimeter. And for wall C and D, it is 36 kN per millimeter. And the center of mass is assumed to be at the center of the area because we have considered the weight of the roof to be uniformly distributed, and we neglected the weight of the concrete shear walls. So we neglected the weight for easier computation, but in reality, we do not. Okay? So in reality, we have to actually get the center of the mass of our structure. Okay? So CM is the center of the mass, and CR here is the center of rigidity. Okay, so what I'm going to do is I'll move to the next slide. Okay, add natin yung photo. Oh. Saan na yun? Yun. So, click natin ito. Lagay natin dyan para mas madali nating ma-view. Okay? So, yung first nating required is the eccentricity and rigidity properties. So, kunin natin yung ibig sabihin nito, kunin natin yung center of rigidity, di ba? I-check natin kasi kung meron tayong torsion presence. Okay. Properties. Okay. The rigidity of the structures in the direction of the applied force is the sum of the rigidities of the panel to this force. So, ito yung ating shear. This is the direction. So, the total rigidity of the structure ay yung magre-resist sa kanya. So, since pag ganito yung ating, yan ang direction ng ating shear, ibig sabihin nga, kaya nang sabi ko kanina, ito yung magre-resist sa kanya, si wall A at saka si wall B. And the rigidity of the structure in the direction of the applied force is the sum of the rigidities of the wall force of the wall parallel to this force. So, ulitin ko, the rigidity of the structures in the direction of the applied force is the sum of the rigidities of the wall parallel to this force. So, that is walls A and B. So, the total rigidity of the structure here is yung rigidity ni A plus yung rigidity ni B. And RA is what? 54 kilonewton per millimeter plus RB is 18 kilonewton per millimeter. So, if we add this one, 54 plus 18, this is 12, 1, 6 is 72 kilonewton per millimeter. So, that is the rigidity. So, we're going to look for the center of rigidity. Dito kasi sa figure, pinakita niya kung asaan. Pero, hahanapin natin yan. So, for us to locate, the formula would be, so, location ha, x sub r ay mula dito. So, ito kasi yung 0, 0 natin. If you notice, nag-draw tayo na may drawing nito ng Cartesian plane. That this is x and this is y. So, this is 0, 0. So, for us to get the location, XR, X sub R is equal to, ano yung ganyan, malayo? That is RB, di ba? So, yung rigidity mula dyan, RB times the distance niya mula dito, that is 24 over yung total ng RA plus RB. Kasi i-consider natin na yung sa A ay 0 na yan. So, RB lang yan. So, we should RB times 24 divide it by RA plus RB. Ano ba yung RB? 18 times 24 divide it by 72. Yan yung location ng X sub R. Ito yung X sub R. Mula dito hanggang dyan. So, that is X sub R. X sub R is what? 18. Wait, I'm just going to look at my calculator. Wait lang. 18 times 24 divided by 72. 6. Class, kung manonotice nyo, di ba hindi naman dapat dito siya sa center nito. Kaso, na-show na lang natin na yung thickness nitong, na masyadong manipis yung shear wall natin, that this thickness, this distance here doesn't matter. Ito dapat yun. So, in-assume na lang natin na ganyan na siya. Okay? Para easier yung ating computation. Kasi maliit lang din naman yung difference. And, so, next is slide tayo. So, or dito na lang sa gilid para hindi tayo magana. Y sub R, location niya mula dun sa y-axis naman. So, yung rigidity naman na involved ay etong paganito, di ba? Kasi we are on the y direction. So, eto naman, so si D, that is, kasi siya yung malayo, RD times 12. Because we are looking for the center of rigidity, kaya lahat ng walls, i-consider natin. RD plus RC. So, Y sub R is equal, this is your lesson in your mechanics. Ito ata yung lesson nyo sa mechanics on how to locate the center of mass, center of rigidity, etc. Diba? So, RD, kasi, bakit 12? Kasi mula dito hanggang dyan, 12 yung distance niya. Ano ba yung RD? RD is what? 36 ba yun? 36. 36 times 12 over 36 plus 36. So, obviously, this is 1/2 of 12 na, diba? Kasi 1 over 2, 1/2 of 12, that is 6 meters. So, yung X sub R natin, meaning, yung center of rigidity natin ay 6 meters mula dito. Nag-move kasi yung ating ganyan. Mula dyan, tapos, yung Y sub R natin, 6 meters mula naman dito. So, parang magkalinya lang sila ng CM. Class, ulitin ko ha. Di ba, ang X sub R, dapat include natin yung thickness ng wall. Dito kasi sa given, hindi niya in-include yung thickness ng wall. So, for computation, ine-neglect na lang natin yung maliit na yon. Okay? So, 6 meters ang Y sub R, tsaka ang X sub R ay 6 meters din. So, ito nga ang center of rigidity. That is 6 meters mula dito and 6 meters naman mula dito. So, ito yung X sub R and this is the Y sub R. Okay? So, that's how we get the center of rigidity. So, next, the next thing that we're going to do is to get the eccentricity, the difference between CM and CR. So, obviously, kung ito ay 12, mula dyan hanggang dito ay 12 meters, tapos ito mula dyan ay 6 meters, obviously, RE is equal to what? E is equal to 12 minus 6. That is X sub M minus X sub R. Yan yung difference niya. So, meron tayong eccentricity na 6 meters. So, ang difference nung CR at CM natin ay 6 meters in that direction. Okay? So, the next thing is we're going to get the torsional rigidity about the center of rigidity. Diba? So, ano yun? Yun yung nasa mechanics natin na J. So, J is what we call the torsional rigidity. Diba? So, how do we get the torsional rigidity? Ang pagkuha niyan, rigidity times distance squared. Tama? Yun ba yun? Or, times the, mula dun sa center, times yung, wait lang. Torsional rigidity from your mechanics. Kunin ko ulit yung photo para madali. Okay, so, Ang torsional rigidity is yung J natin. That is what we call the torsional rigidity. Para makuha natin yan, rigidity times the distance squared mula dito sa center of rigidity natin. So, lahat ng wall natin, i-involve natin dito. So, first natin ay si A. So, si RA, ano yung rigid RA? So, ang distance niya ngayon mula dun sa CR natin is 6. So, distance is squared. Okay? Plus, sinong next? Si B. Distance RB times yung distance niya mula sa center of rigidity. Obviously, since 24 minus 6, this would be 18 squared. Ulitin ko ulit, class. Baka malito kayo kasi, ma'am, dapat included yung thickness of the wall. Dito nga neglected na yung thickness of the wall kasi dun sa problem, hindi naman niya sinabi. Okay? So, for the purposes of computation, we shall neglect the thickness of the wall na lang. Okay? Baka hindi nyo pa kasi ma-let go yung concept na yun eh. So, saan ako? Torsional rigidity, ulitin ko, that is rigidity times the distance squared. So, RA times yung distance niya sa center, 6 meters. Tapos, RB, yung distance niya from the center, that is 18 meters. And RC, distance niya mula sa center, ito yung center natin. This is our center of rigidity. Distance niya mula dyan, that is 6 meters. Okay, so, RD naman, rigidity, distance niya mula dyan, that is also 6 meters. So, RD 6 squared. So, that's how we do it. And we're going to substitute the values. 54, 6 squared plus 18, 18 squared plus 36, 6 squared, same, 36, 6 squared. Okay, total. Going to write this one on our calculator. So, this is 10,368. Rigidity, kilonewton per mm meter squared. Diba? So, ito yung ating ang tawag dito, torsional rigidity. Now, the seismic force V will be applied at the center of the mass. Kaya ngayong V natin dito nakalagay eh. So, RV, the seismic force be applied at the center is equivalent to having V applied at the center of rigidity together with a counterclockwise torsion. With the requirements for having accidental eccentricity E sub ACC. Meron to sa SCP natin, the accidental eccentricity. The total shear on walls A and B can be found by the addition of direct and torsional load cases. So, first nating gagawin is the direct shear distribution. Okay? Direct shear. Asan ba yung direct shear? Wait lang. Ito na lang. Yung pick na lang natin kanina. Okay. So, ito naman, nasa ano tayo? Nasa direct shear computation tayo, di ba? Wait. How do I... Okay. So, for the direct shear, ang sabi kanina, the seismic force be applied at the CM is equivalent of having the V applied at the center of rigidity together with a counterclockwise torsion. Diba? So, meron tayong counterclockwise torsion with the requirements for accidental eccentricity EACC. The total shear on the walls A and B can be found by the addition of the direct and torsional load cases. Meaning, the V applied at the CM, ililipat natin dun sa center of rigidity but with a counterclockwise torsion. Okay. So, first, nasa second requirement na tayo, number 2, we are going to get the direct shear. So, nasa direct shear na tayo. Nakuha na natin yung ating eccentricity and rigidity properties kanina. So, for the direct shear, ito yung V natin applied at the center. So, ang direct na maggaganyan sa kanya dyan, ang direct na, ang gagawin pala natin, ililipat natin siya, diba? Kaya yung direct shear na nilalagay natin dito. Okay. Sige na nga, nakakalito. Dito na lang muna siya, total direct shear, wala pa naman tayo sa torsion. Okay, so, since ganyan yung shear natin, ang direct na kukontra sa kanya, ito, si V, tsaka si VA, tsaka si, so this is VA and this is VB. Since direct naman na ganyan yan, direct na kukontra sa kanya, so direct shear contribution. So, how are we going to solve direct shear contribution? So, madali lang, VA, I'm going to write D pala dun sa ganyan niya para hindi tayo malito. So, V, D, A, and V, D, B. Para alam nyo yung direct shear yan. Okay? So, the formula, ganyan lang to, anong tawag dito? Proportional, diba? So, ang RA natin over yung total, kung ano yung rigidity over the total rigidity times the V. Directly proportional lang siya. So, ganun din sa B. So, this is the direct shear. So, ano ang RA natin ulit? RA is 54 over 72. Tama? 54 over 72. Times 450 and 54. This is 18. 18 over 72 times 450. Okay? So, this is 337.5 kilonewton and the other one is 112.5 kilonewton. So, yan yung direct na contribution ni direct shear na pinaghatian ni A tsaka ni B natin. So, that is our direct shear. Yan yung ganyan niya. So, depende siya sa rigidity. So, for the A, mas malaki kasi mas mataas yung kanyang rigidity. So, that is the direct shear walls in A and B. Okay? So, next one, we're going to get the, ano ba yung next dito? The plan irregularity requirements pa pala. Okay. So, the determination of torsional irregularity, it is in our table 28-10. Diba? Dun sa number 1 siya, diba? Item 1. Requires that the evaluation of the story drifts in walls A and B. This evaluation must include accidental torsion due to an eccentricity of 5% of the building dimension. So, tsaka ko muna yung add to. So, 3 requirement natin is plan irregularity requirements. So, the determination of torsional irregularity, item 1 in table 28-10 requires the evaluation of the story drifts in walls A and B. This evaluation must include accidental torsion due to an eccentricity of 5% of the building dimension. So, we're going to include accidental eccentricity, diba? I mean, eccentricity due to accidental torsion, and that is 5% of the building dimension. Anong dimension yun? The one na yung, kung asaan yung line ng ating, anong tawag dito? Yung yung perpendicular dun sa ating shear. So that is 24. So this would be what? 5% of 24. So accidental eccentricity due to accidental torsion natin is 1.2 meters. So the corresponding initial most severe torsional shears using the accidental torsion of 1.2 meters . 1.2 Okay, so next thing is we're going to get the the corresponding initial most severe torsional shears. So we're going to get the initial torsional shears using the 5% na EACC. So i-assume muna natin yung 5% na eccentricity. So yung initial natin, so kukunin natin yung I'm going to put in ito, this is initial, meron siyang prime, T, that means torsion, and A, kasi nasa A tayo. So, before ko pala i-ganyan yan, ilagay ko na lang kung paano pala natin kukunin yung ating i-drawing yung ating torsional shear. Okay, so, ito yung drawing natin kanina. How are we going to draw a torsional shear? Diba sabi kanina, class, kapag ganyan, we can transfer diba the V is in the cm, but we can do that, we can transfer that. Pwede nating ilagay yung ating V. Pwede nating i-transfer yung ating V dito sa ating CR. Tama? Provided that is equivalent to having B applied at the CR together with a counterclockwise torsion. So, we're going to have a counterclockwise torsion. So, counterclockwise torsion. Hey, so, ganyan yung kanyang effect. Diba? Kasi, andito siya sa ganyan andito siya sa left ba? Oo, left. Yung CR natin nasa left ng ating application of shear. Kaya yung kanyang movement, class, ay ganito. So, meron tayong counterclockwise na torsion. So, along with the torsion. So, okay. Wait lang. So, ito, i-drawing ko na lang yung torsion dyan. Okay, so we are on the part kasi na ng torsional shear na. So, counterclockwise torsion. So, ang ating V, ang kanyang ang V natin ay ganito. So, ito yung kanyang movement. So, V, TC, V, TD, V, TA, and V, T. Oh, B pala yun. Sorry. So, this should be V, T, B, and this should be. So, yan yung ating torsional shear. Wait lang. I-correct ko lang yung distribution ko kanina. So, eto, palitan ko na lang yung drawing ko dito. So, since ang gagawin naman natin ay ililipat na, so, ganito na lang, class, ha? Ito ganito sa direct shear V. Since ganyan yan, yung direction niya hindi siya opposite, the same. So, VDB, VDA. Okay. So, that's how we do it. Okay, so ganyan siya. Next is, anong gagawin